Welcome to all. Today the topic is applications of group theory. So what we discuss today, basically topic is applications of group theory. Applications of group theory. So let's talk some general things that we know the degree of freedom. Degree of freedom we know that is generally 3n. Means a degree of freedom for atoms for total degree of freedom of a molecules that we say that is, let's say, if I write total degree of freedom of a molecules is, that is, we can say that is equal to 3n, where n is, where n I can write where n equal to number of atoms present in the molecules. Present in the molecule. So we know that we have two types of molecules. One is, we can say, linear. Other type is non-linear. And for linears, we can say that translational. So degree of freedoms, that is total degree of freedom 3n. That can be three types. Either it is translational, either it may be rotational, or it may be the vibrational. Okay, so now I am writing first translational and rotational and vibrational. So we know that for translational, linear, how many translation are there? 3. For non-linear also 3. And rotational, for linear is 2, translational is 3, and vibrational is total minus translational plus rotational. That is, total is 3n minus translational plus vibrational. Here also we can say 3n. Sorry, 3n minus translational plus rotational, and we say that translational are 2, 3, 5, 3n minus 5, here 3n minus 6. So these are the general things we know about of the degree of freedoms, how we will know the translational, rotationals and vibrational. So here that we generally assume that we say that for translational 3 are there for linear and 3 are there for non-linear. Similar rotationals for linear 2 and non-linear 3, and we calculate that vibrational total minus additions of this translational plus rotational. But when we discuss about of the degree of freedoms in group theory point of view, what we say that we will look the character tables. From there we will say that how many translational are there, how many rotational are there, how many, and from that we will calculate the vibrationals. So for generally we assume that we say that this is 3 and this is 3 and this is 2, 3 for general cases that we know in like in previous classes. But for that apply for group theory, in point of that we will look the character tables. From that we decide that how many translational are there, how many rotational are there in the molecules. So that we will discuss today, and we will discuss which are the IR actives, which are Raman actives, and which are the both IR and Raman active. Okay, so let's proceed. So one point group will be given to you, the character tables will be given to you. Let's say I am taking about a C2B point groups. Any point group will given to you, and with that we will calculate, or it may also given to you that reducible representation and irreducible representations. If not given also, we can easily calculate. After that, by looking the character table, we can say that how many translations are there, how many rotationals are there, and we can calculate from that vibrationals, and from vibrational we will calculate that IR actives and Raman actives. Okay, so let's proceed. So let's say character tables, we have the C2B character tables. Any character table is may be given to you. So here we are assuming C2B point groups is given, and C2B point groups, the atoms like water. This is H1 and this is H2. So from this character table, first we will calculate that irreducible representations, and in the exams maximum times that irreducible representation also given to you. From here we just want to calculate irreducible representations also. So we are calculating, but it is given in question paper itself. For time being we are calculating. So C2B point groups, what are the symmetry elements? E, C2, sigma and sigma dash. So here let's say I'm taking this as the axis for me. This is x-axis, this is y-axis, and it is z-axis. So I'm applying that this C2 axis in y-axis, and I have the plane. Let's say this is xy plane, so this is xy plane. This is sigma xy, sorry, yz plane. This is yz planes. Another I have we can take another planes I have. Cutting all the atoms, that is sigma, that is yx planes. So I can say this is yz, let's say, and this is yx planes. Okay, so now what I will calculate that number of unshifted atoms. We will calculate first. So number of unshifted atoms when you apply E is no change operation. So all the three atoms will not change its relative position. So 3 and C2, whenever I will apply C2, then this replace, means this oxygen will change, and which are the not change means number of unshifted, which are not shift, only oxygen is not shift. So 1 and sigma yz. So if I applying this plane, then only oxygen will not shift, this will shift. So number of unshifted 1, and whenever I apply sigma yx, means cutting through all the atoms, on that case all the three atoms will not shift. So number of unshifted atoms are 3. So now I will use that characters. So character of E is 3 and C2 is -1 and sigmas are all 1. So if I multiplied it for getting the reducible representations in 3n coordinate systems. So this will be 9, this will be -1, this will be 1, this will be 3. So these are the reducible representations in 3n coordinate systems. Now using these 3n coordinate systems, we will calculate the irreducible representations. So formula of irreducible representations is summation ni, xi, yi and zi, where xi is characters of reducible representations and yi is characters of irreducible representations, and zi is coefficients of symmetry operations or symmetry elements. So we can calculate. So let's calculate first. Okay, let's calculate for an A1. So I'm calculating first. This is A1. So first is characters of reducible representations. So this is reducible representations. Character is first, that is 3. So I will use that 3. Oh, sorry, here order of the point groups. Okay, where H is order of the point groups. So here order is, this is CNB type, so order is 2n. So here the 2 into n is here 2, that is equal to 4. So I can say 1 upon 4, and will not do the summation, that I will use. So xi is how much? First is reducible representation. This is reducible representations, character of reducible representations. So this is 3. So I can use 3 into, after that, where is the formula? This yi, that is characters of irreducible representations. So e is 1. I will have use 1, and after that coefficients of symmetry element, that is 1. So 1. Similarly, we can find for next, this we will say next C2. So for C2, that is character is 1 into this is 1, and this is again 1. Okay. Similarly for sigma, that is 1, this is 1, and that is 1. So I think 1, and this is 3, and this is 1, 3, 3, 1, 1. Okay, so that is 3. So if we calculate it, then what we get? 1 upon 4. So this value is, so 3 plus 1, that is 3. Okay, sorry, this is, this character of reducibility 9 will put, not here. Okay, sorry for that. This is 9, and this C2 is minus 1. Sorry. So I am calculating for A1, sorry, that is order 1 is 1 upon 4, and characters of reducible representations. So this is the reducible representation, the character is 9. Okay, so 9 into irreducible representation, these are the irreducible representations. So correspond to E is 1. So 1, and the coefficient, that is into 1. Okay. Coefficient is from here we will take the coefficients, here 1, here 1, 1, 1. Okay. So 9 into 1, 1, plus next is C2. For that, the irreducible representation is minus 1, and after that character is 1, and coefficient also 1. So I can use 1 into 1 into 1. After that I can say this is sigma, that is 1. So 1 into, and the characters for this also 1, and coefficient also 1. I can put 1 into 1 into 1. After that this is 3, and that character is also 1 into 1. Okay, so here we can calculate, and A1 is equal to 1 upon 4, that is 9, and this is minus 1, and this is plus 1, and this is plus 3. So if you calculate it, then this is how much? 1 upon 4, this is cancel, and this 9, 3, that is 12. So for 3, that is equal to 3. So NA1 is equal to 3, and similarly we can calculate for NA2. So here how much? Now we will go for this. So these characters we will look now. These characters we will look now. Previously we were looking these characters. Now we look these characters. Okay, so first I will use, these are all 1, 1, 1, minus 1, minus 1. Okay, so I will use that. That is first order, then 9. After that the characters are 1, and this is also 1. Okay, so this is 1 into 1 plus another is this is minus 1. After that, that is also 1 and 1. So I will not do, and after that I will direct put in the value. After that plus, and this is 1, and that characters are minus 1 and 1. I will put minus 1. After that, next is 3, and this is minus 1 and minus 1. So this will get minus 3. Okay, so if you calculate it, 1 upon 4, this is 9, and this is minus 1, and again this is minus 1, and again this is minus 3. So if you calculate whole, then we will get, that is minus 3 4 minus 5, that is equal to 4. So this is going to be 1. So Na2 we will get 1. Similarly we go for NB1, then order is 4. So again we will get that we will go for this value B1. So this is 1 minus 1 1 minus 1. Okay, so first we will go for 9. So 9 9. After that, this is, now we are looking these characters. So 1 and 1, 1 into 1 plus next is minus 1, and these whole values are, this is minus 1 and 1. So this is again minus 1. After that I'm going, coefficient is always 1 1, so I'm taking that one. This is 1, and this is 1, and this is 1, so this value comes to be 1. After that another is 3, this value is 3, and that characters are minus 1 and 1. So I will get here minus 1. So if you calculate it, then we will get 1 upon 4, this is 9, and this is plus 1, and this is going to be minus 3. So if you calculate it, then 9 1 upon 4, this 9 minus 1 10, there is 7. Any wrongs? 9, that is minus 1, and here also minus 1, then this is the 1, and this is, oh, one value we forgot, then other is 1 is also there. So yes, plus 1. After that this is minus 3, because 4 characters are there, right? And 9, that is minus 1. So this is 8, that is equal to 2. NB1 2. Similarly, if you calculate for NB2, then this is 1 upon 4. Will use other pen. So now for these characters, we are using these characters now. So this is 9 first 9 into, full value is 1 into 1 plus, now this is minus 1, and this is also minus 1, so it's going to be 1 plus, now next value I am using, this is 1, and this is again minus 1, so this value is going to be minus 1, and last value is 3, this value 3, and these are 1. So this is the character. So if you do the operations, then 9 plus 1, this is minus 1 plus 3, so this cancel, that is 9 3 12. So for 3, so NB2 is 3. So what are the characters we have? Characters we have, that is NA1 is 3, so 3A1 plus, this is A2 is how much? 1, So A2 plus B1 is 2B1 plus this is 3B2. These are the total modes. These are the total irreducible representations. These are the irreducible representations. So we can easily check also whether this answer is correct or not. So I will write here what the irreducible representation we get, that is 3A1 plus A2 plus 2B1 plus 2B1 plus 3A2 plus 3B2. So if you, how you will do, if I multiplied here with 3 and if I multiplied 1 and if I multiplied with 2 and if I multiply with 3, then after that I will get this value, then my operations is correct. So let me do the operation. So here 3, here 3, here 3, here 3, here 1 1, here 2, here 2, here 2, here 2, here again 3. So what the value I will get? This is 3 1 4 4 5 6 7 8 9. So 9. Okay, next 3 1 4, this is minus 2, again 2, this is again minus 3, this is minus 3, this is minus 3, this is minus 2, minus 5, and this is 3 1 4. Okay, 3 1 4 and 4 minus 2 2 and minus 3, that is going to become minus 1. So minus 1. Okay, next this is 3 1 minus 1, that is 2, and this is 2, then 4, this is minus 3, 4 3, that is 1. Okay, 1, and this is 3, this is minus 1, that is 2, and this is minus 2, so 0, and this is equal to 3. So same value we are getting, means our operations is correct, means our calculations is correct. So these are the irreducible representations. So now what we have seen, that we have said that any molecules, a molecules is there, molecules, total degrees of freedoms, total degree of freedom is 3n, and here we will say that linears and non-linear research, and this translationals, rotationals and vibrational. Translation we say 3, here also 3, rotational here 2, here 3, and vibrational we say that 3n. After that this additions, that is 5 minus, and 3n addition, that is minus 6, that we say. So here that 3n is actually equal to this. Okay, so this irreducible representation we say the total modes, or we can say the total degrees of freedoms. So for now, from group theory point of view, what we say that this 3n for me is equal to this value for group theory. Okay, so this 3n is equal to 3a1 plus a2 plus 2b1 plus 3b2. So from here, but I will look for translationals and vibrationals. So for these molecules, for this type, so what you say that translational we say 3, and non-linear linear 3, and non-linear 3, and rotational here 2, here 3, and vibrational we total minus this, we are doing like that. So for now, what we say that translational we will not say 3, we will look from this point groups and say that how many translational are there, how many rotationals are there. So this is equal to 3n. This is the total modes. So from here, what we say that for general, what we say linear and non-linear, and for translation that is 3, and non-linear that is also 3. Rotational this is 2 and this is 3. But for this point group point of view, what you say that we will calculate by taking help of the character tables. So I will do, we will go to this character tables. So it is needed to draw the character tables again, and I think this is get a little bit. C2B point groups, E, C2, sigma and sigma dash, and this is A1, this is A2, this is B1, this is B2, and this is 1, 1, 1, 1, this is 1, 1, and this is 1, minus 1, minus 1. Now we know that how to draw the character tables. We already discussed. This is minus 1, 1, minus 1, this is minus 1, minus 1, and 1. Okay, and here this is the character tables. What things are there here? I think this is X is there, and this is RY, and this is Y, and this is RX, and here I think XY, YZ, and Z square and X square, like this are there to look. Z, RZ, XY. So this is Z, this is RZ, XY, and this values, and here I'm wrong. X square, Y square, Z square, and XY, XZ, and YZ. So here that X square is there, Y square is there, Z square, and here XZ, here YZ, ZYZ, and last is XY. Sorry, this is XY, this is XZ, this is YZ. So this is the C2B character tables. From these character tables, we know that the total modes 3, and we know that, and unlike this, we will calculate that how many translational, how many rotationals are there. So total, you have the 3n equal to, that is 3n equal to total modes. We have C A1 plus A2 plus 2B1 plus 3B2. These are the total modes we have. So from here we will calculate that how many translationals are there, how many vibrationals are there. Okay, so for translational, what you do, check X, Y, Z axis, or you can say axis, or you can say that transformations of X, Y, Z axis. So here actually check that X, Y, Z axis is present or not. So like we know, so you know that for generally we say that translational means 3, for linear and non-linear this is 3, and rotational this and this we used to say, but for point group point of view we will calculate it. Okay, so how to calculate translational? We will check that X, Y, Z axis are there or not with respect to this point, this total modes. So here what you said that we will check one by one, where A1, this is A1. So this A1, whether it has any X, Y, Z axis, anyone is present, then that is translational active, means translational is there. So for this, let's say A1, so X, Y, Z, yes, Z axis is there. So A1, Z axis is present. So this is translational modes are there. Okay, Similarly, next we will go for A2. So for A2, this RZ XY, this is XY, not X and Y. This is XY. So this you can say that this XY, YZ, or ZX, or X square and Y square and Z square. These are the quadratic functions. Quadratic functions. So this we will check for Raman actives or not. Another is Rx, Ry and Rz. These are the rotational. For rotational, we will check this x is present or not. Okay. So for translational, we will check x axis, z axis, or y axis. So for A2, we see that no, that kinds of axis is not there. X and y and z not there. So this is translational inactive. So no axis. So no translationals. And now we will look for B1. So for B1 is there. Yes, x-axis is there. So this is x-axis is there. So this is translationals. Now we look for B2. So for B2, y-axis is there. Okay. So any one is present, then that is translationals. Okay. So what you see that A1, B1 and B2s are translationals. Okay. Similarly, for we will go for rotationals. For rotational, what you will look, check Rx, Ry and Rz. Okay. So first we will go for this all one by one. This whole modes we will check. So A1. So for A1 case, not there. Z axis is there, but Rx is Rx, Ry, Rz not there. So this is no rotationals. And let's go for A2. So for A2, this is A2. So yes, Rz is there. So Rz present. So this is rotational. Rotational modes are there. Let's check for B1. And B1, we see that Ry is there. So Ry is there. So this is the rotational modes is present. Next we go for B2. For B2, yes, Rx is there. So Rx is there. So this is again rotational. So what are that active? And this is A2 is there, B1 is there, and B2 is there. So what we see that we should remember one thing. Whenever we are calculating for modes, then will that here 3A1 is there. But whenever we are calculating for rotational or translational modes, if A1 is there, if for A1, let's say z-axis is there, then we consider only A1, not we will not write 3A1. If you write, then this will be will not get that vibrational mode. So we will take only single value. Okay. If you take that 3A1, then this will get cancels and we will not get the vibrational modes. But actually you are doing what? The total is this. From here we will add translational and rotational to get the vibrationals like this. These are the vibrational, translational, rotationals. For getting vibrationals, what you are doing? We will add the total. Total is 3n minus this 2 we will add. So similarly, like here, the 3n is this. So from here, what you will do? We will subtract this translationals and this rotational. You add this one and subtract from this total. Okay. So for that, what we say that if A1 is translational modes is there, then we only will write A1, not 3A1. We will not write 3A1, only A1. If you write 3A1, then we will not get the vibration because this whole will get cancelled up and we will not get. Okay, so we will write only A1, and here also if A2 is present, only we will write A2. Here B1 is present, so we will not write 2B1, we will write only B1. Okay, so whenever we are doing for modes, on that time we will not take the coefficient, or stoichiometric value. Okay, so vibrational modes modes are, what you say, that 3n minus rotational plus translational. So here our 3n is, this is our 3n, that is 3a1 plus a2 plus 2b1 plus 3b2, okay, minus the rotationals are, what are the rotationals? This a1, b1 and b2, okay. We will write single, that is a1 plus b1 plus b2, and rotational, this is translational plus rotational are a2 plus b1 plus b2, okay. So vibrational modes are, that is, I can write 3a1 plus a2 plus 2b1 plus 3b2 minus a1 minus a2, how many b1? 2b1 minus 2b1, and how many b2? Minus 2b2, okay. So if I write like, that a2, a1s are for this translational, a1 is totally, I have 2a1, 3a1, then if I write here 3a1, then I will not get, because this 3a1, this 3a1 get cancels. On that case I will not get vibrational modes. So whenever I will write one point, for modes calculating, not take stoichiometric coefficients, okay. So now if you do it, then how will you get vibrational modes? This is equal to 3a1, that is minus a1, that is going to become 2a1, and a2 get cancels, and 2b1 and this 2b1 get cancels, and 3b2 minus 2b2, that is equal to plus 8 plus b2. These are the vibrational modes. From vibrational modes, what we say, that from here we will calculate whether these are IR actives, whether these are Raman actives, or whether these are both IR and Raman actives. So after calculating that vibrational modes, we will look whether these are IR active, whether these are Raman active, and whether these are both IR and Raman active. So for IR active, what you will look here, again check transformations with respect to x, y, z axis. So we will check that whether x, y, z axis is present or not to this this, what you say, this what Malki notations. And for Raman active, what will that check quadratic functions. Quadratic functions means you say that x, y, y, z, or x square, y square, that type of functions, okay. And for both Raman and IRs, if both these actives, then that will fall in this category, okay. So we have this 2a1 and b2. So these, from here we will check whether these are IR actives, or whether this is Raman, and whether this is both IR and Raman active. Okay, so now again we will use that character tables. So we have the vibrational modes are 2a1 and b2. So vibrational modes we have 2a1 plus b2. So from here we will check whether they are IR active or not. For IR active, what we will say? X, Y, Z axis is present or not. So A1, this is A1. X, Y, Z axis is present. Z axis is present. Then this A1 is IR active. So where I write? So I will erase it. So vibrational modes we have this one, and for IR active or not, what we will check? So for IR active, we will check X, Y, Z axis present or not. If present, then that are IR active. Okay. So we will check both A1 and B2. So for A1, whenever we will check, we see that Z axis is present, means this A1 is IR active. So whenever we are talking about active, on that time we will use the stoichiometric coefficient. So A1 active means how many A1 are there? 2A1. So 2A1 is 2A1 IR active. And let's check for B2. So for B2, we see that B2, Y is there. So these are again B2 IR active. And here which axis is there? This here Z axis is there, because Z axis is there, here Y axis is there. Okay. Similarly for Raman actives, what you will do? X, Y, Z axis means X, Y, Y, Z, that things we will look. So let's look for that A1. So A1, is there axis are there? Yes. So these are the quadratic functions are there. Then this is Raman active. So how many A2s are there? 2 A2. So 2 A1, these are Raman active. And for B1, if I check, and for IR, we will look Z axis. What I'm going? I have B2. So B2, again that YZ functions is there, quadratic functions. So this again B2, these are again Raman active. So likewise we will look that. So note here one thing, that whenever you are talking about of this IR active, Raman active, on that time include for checking Raman IR active or not, use stoichiometric coefficient. Stoichiometric coefficients. So here A1 is active, means 2 A1s are IR actives. Okay. Similarly B2 is active, so B2 is IR active. Here A1 quadratic functions are there, then this is Raman active. Similarly B2 also quadratic functions are there, then this is again Raman active. Okay. So for both IR and Raman active, so both are IR and Raman active. This is also IR active, this is also Raman active. So we can say here, that 2A2 plus B2, these are IR active, and here also 2A1, this is A1, sorry, 2A1 plus B2, these are Raman active, because both cases XYZ axis is there and that quantity functions is there. And next thing is both IR and Raman active, so both are IR active and both are Raman active, so both again 2A1 plus B2, these are both IR and Raman active. Okay, so this is about of that character tables of water cases. Another, if you take the examples, let's take another examples, that is cis butadiene. So this in exam many times this question is asked about of cis butadienes. So let's look examples of this also. So this, how will look this structure, this is somehow like this. Cis means this, butadiene, diene means two double bonds are there. Okay, so methane, ethane, propane, butane. So complete now, CH2, CH2. This is the structure. So this you can write, this is the butadiene structure. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, total 10 atoms are there. Okay, so here also if you draw the character tables, then how can, this is also, we see that this is also C2B point groups. This is like water type molecules. Okay, C2 is there, and here also this is there, and this is there. So this is also a C2B point group. So character tables will be here again. I can write E C2 sigma and sigma dash, and I can write here A1, A2, B1 and B2, and this is 1 1 1 1, this is 1 1 1, this is 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1 and 1. And similarly here also we have two functions. Here we have, let's say, x and y, then this is ry, and then this is rx, and let's say this is here x square, y square and z square, and here we have y x, here x z, here we have y x, here x z, here we have y z, and here we have that z and rz. Here have z and rz. These are the character tables for C2B point groups. So what we will look past, we will calculate the reducible representation in 3n coordinate systems. So we will calculate the 3n reducible representations. We will calculate here. So this is the molecules. This is the molecules. So that this is C2B. Here E, C2, sigma and sigma dash. So number of unshifted atoms, first number of unshifted atoms. After that we will calculate the character. So character, you know, this is 3, this is -1, these are the 1 1. Okay, so now we will look for this number of unshifted atoms by applying this symmetry operations. So if I apply E, then nobody will change. So total whole atoms will remain in its own positions, means number of unshifted atoms are whole atoms, because no atoms will change, because E apply, then no body will change. So this is actually how we look. See here, this is C, let's say CH2, CH2. So how many total atoms? 1 2 3 4 5 6 7 8 9 10. So total 10 atoms will not change if we apply E. And C2, if I apply C2, let's say this is my x-axis, y-axis, z-axis. So if I apply C2 along y-axis, then whole atoms will change. This will go here, this will come here. Similarly, this whole extent, so this is 0. And if I apply that sigma, let's say yz plane, if I apply that yz planes, then also this whole will be changed, then this is also 0. And first we have to look that which planes here we are using here. So this and this we have to keep it same, because you see that here b1 and this is we are using, this is molecular plane. If we are using this molecular plane, here also we have to use the molecular plane. So now I will take this plane here, because this and this need to be equal, so that whenever you are checking, then on that time it will helpful. So here also I will use this, so I will use this y-axis plane, and this I will use the yz plane. Okay, so y-axis plane, so what that if I apply that planes, y-axis means no atoms will change, so full 10. And if I apply this, then nobody will change, that is 0. Okay, so whenever you add it, so 3n coordinate systems irreducible representations are, that is 30, this is 0, 10, this is 0. So these are the irreducible representations. Now if you go for that irreducible representations, then what you will look for irreducible representations, that is 1 upon order h xi yi zi. So now what you will do, first we will go for a1. So similar way as you have did for water case, you also you do same things. So if I represent for a1, then this point group will be again 4, because this is C2b, and xi is 3, so xi is irreducible representation, that is 30. Okay, so 30, and irreducible representations is 1, and that coefficient is also 1 everywhere. Okay, so I can get 3 into 1 into 1 plus next I will go for 0. If it is 0, then whole terms will be 0, so I am not going there. And this is 10, this is 10, then this is 1, so this is going to be 10, and this is 0 means whole terms will be 0. So this is going to give 1 upon 4, that is 30 plus 10, that is equal to 40. So this value will be equal to 10. So na1 is equal to 10. Okay, similarly if I go for na2, that will be 1 upon 4. So now I am going for this. So now this is 30, and this value is also 1, and the coefficient is also 1, so this will be 30. This is 0 means whole terms will be 0, and this is 10, then I will go for here, this is -1, so this will be -1. Similarly, that is 0 means whole terms will be 0. This will be equal to 1 upon 4, this is 30, this is -10, that is equal to, that is 20, and that is going to be 5. So na2 equal to 5. Similarly you go for nb1, that is equal to 1 upon 4, first is 30, I am going for this one 30, and next term is 0, and next is 10, so this is 10, then I have to go for again this sigma also, this is 1. Okay, so I will get 10 itself, so another is 0. So if you calculate it, then what will get, again we will get that 40, again we will get 10. So nb1 is again 10. Next we will go for nb2, then again 1 upon 4, again this is 30, and second one is 0, I will not go for, and next is 10, So I will look for here -1. So this here again -1 value has come. So this value is again -10, again is going to get 5. So NB2 is again 5. These are the characters we get. So what the characters we get? That 5, that is 10A1 plus 5A2 plus 10B1 plus 5B2. These are the irreducible representations I get. So whether it is correct or not, how will you check? I will write 10, 5, 10, 5. Okay. So I will write 10A1 plus 5B2 plus 10B1 plus 5. This is A2 and 5B2. Okay. This one I get. So whether it is correct or not, how will I check? Multiplied it here 10, 10. So if I multiply here 10, 10, 10. So 10A1, here I will multiply 10. Here I will multiply by 5. Here I will multiply by 10. Here I will multiply by 5. So if I multiply, then this is 10, this is 5, this is 10, this is 5. So 10, 20, 5, 25, 30. So I am getting 30. So this is same as the relative representation. Then it is correct. Now this is 10, this is 5. 10, 5, 15, and this is -10 -5, whole is equal to 0. Another this is 10, this is -5, then -5, this is 10 -5, again I will get. So 10 -5, that is -10 -5, that is 5. Here 10 -5, again 5, 5, 5, 10. So again this is right. This is 10, this is -5, 10 -5, that is 5. Here -10 and 5, that is -5, whole equal to 0. Okay, so our operation, our calculation is right. Okay. So after getting that irreducible representations, we reuse the same things as we used for water case. So what I will do, I will just erase it. So after doing that, these are not important. These are used for calculating these irreducible representations. After you get, I will erase it. Now I have only functions with this irreducible representation and the character tables. These things now not important, not necessary. So I will erase it. Now you see that total modes equal to 3n, we are saying, and 3n here is equal to 10A1 plus 5A2 plus 10B1 plus 5B2. Okay, these are the total modes. So these total modes, what we are saying, that we are calculating the translational, rotational and vibrational. So for point group point, what we say, that we use that character tables, how many translational, how many vibrationals are there. So for translational, what we will look, XYZ axis. So XYZ axis, note that for IR active, after getting vibrational modes, for IR active also we are using that XYZ axis, and for translational modes active also we are using that XYZ axis. Okay, so for translational we have to check XYZ axis is present or not. So first we will check with A1. So A1 case Z axis is there, then this is translational, and we will look B1 is also there, A2 is also there. We will check for A2. Not XYZ axis is there, so not translational. And B1 again X axis is there, so this is translational. and B2, B2. Yes, Y is there. Again, this is translational. So translationals are, so I will erase it. These are not necessary now. Okay, so translationals are translational modes. This is not there. After that, this are there. So here we will not use the coefficient. So I will simply write A1 plus B1 plus B2, and this is not there. Okay, so these are the translational modes. And for vibrational, what it look for vibrational? Sorry, for uh, rotational. For rotational modes, what you will look? We look Rx, Ry, and Rz. Okay. So similarly, we will check again for A1. Rotational modes are there? No. So this is no rotational modes. And look for A2. So for A2, I think yes, A2 is there. So rotational. And let's check for B1. So for B1, yes, that is there. So B1. So this is rotational. And V2 also rotational is there. Okay. This is also rotational. So rotational modes are we will write not, we will not use the coefficient. What are that? A2 plus B1 plus B2. Okay, these are the rotational modes. Okay, so now for vibrational, what you are saying? We know that for vibrational, what are doing? 3n minus rotational plus translational. So here the 3n is the total modes. So total modes we have this. So 10A1 plus 5A2 plus 10B1 plus 5B2. Okay, now we will minus our this one. I will add it. Okay, now I am doing the other pen, that is I can write this pen. Translational are A1 plus B1 plus B2, and rotationals are A2 B1 plus B2. Okay, so now if you do it, I will erase it. It's not important. Okay, so 10A1. So this is vibrational modes are, so 10A1 plus 5A2. These are the total, plus 10B1 plus 5B2, and this is also not important now. Then minus, this is A1. So I will simply write this minus A1, and B1 are 2, so minus 2B1, and B2 also 2, minus 2B2, and A2 is 1, so minus A2. So if we calculate it, then we get the vibrational modes. So 10A1, that is 9A1, 5A2 minus A2, that is plus 4A2, and 10B1, this is 2B1, so this is 8B1, 5B2, and 2B2, that is 3B2. So these are the vibrational modes. Vibrational modes. Okay, so is it right? Na1, Na1, 2, 2, 4A2, okay, 10B1, 2B1, 8B1, 2, 3B2. Okay, so these are the vibrational modes. Now from here we will check that whether IR actives, Raman actives, and both IR actives or Raman active, that we will check now. So you use these character tables again. So I will erase it. Because I have to use the character tables. By looking character tables, so vibrational modes are, I will write above so that I will. Vibrational modes, what are the vibrational modes I got? Modes are 9A1, 4A2, 8B1. So 9A1 plus 4B2 plus 8B1 and 3B2. 8B1, anything wrong? 9A1, 4A2, 9A1, 4A2 plus 8B1 plus 3B2. These are the vibrational modes I get. So from here I will look that which are the Raman actives and which are the IR actives and which are the both IR and Raman active. So A1, if you look, so for A1 we will look that for IR active, for IR active which are looking after calculating the vibrational modes. From vibrational modes I am looking the IR active. So IR active, what we say that X, Y, Z axis. If you look, okay, so for IR active, so X, Y, Z axis I look, so one by one I will look. That's it for A1. A1 Z axis is there, so 9A1 are IR active. Similarly, A2 is there, so nothing is there, that Z, X, Y is not there. So for whenever you're looking for active, whether this is IR Raman active, on the time coefficients we will use, stoichiometric coefficient we will use. Whenever you're looking for modes, on the time stoichiometric coefficients we will not include. Okay, so here I will include the coefficient. So for A2, X, Y, Z axis is not there, only RZ is there, and this quality function is there. These are IR inactive. These are IR active. Similarly for B1, how many B1? 8B1. So B1 axis is there, this is IR active. And similarly, if I look for B2, how many B2? 3B2. So Y axis is there, so this is again IR active. Which is not IR inactive, that is A2. So if we leave A2, then all are IR active. So now I will erase it. So IR actives are 9A1 plus 8B1 plus 3B2. Now we will look for the Raman actives. So for Raman, what we will look that quadratic functions. So let's say for a1 quadratic functions are there, then these 9a1 are quadratic, these 9a1 are Raman active. So 9a1 are Raman active. Similarly, we look for a2. So a2 any quadratic functions is there? Yes. So how many? For a2 these are Raman active. And if you go for b1, so 8b1 are there. So b1, yes, quadratic function is there. So again this is the Raman active. And next is 3b2. So b2 quadratic functions, yes. So this is also Raman active, means all are Raman active. So I can say that 9a1 plus 4a2 plus 8b1 plus 3b2 means all vibrational modes are Raman active. All vibrational modes are Raman active. Okay, so this whole vibrational modes are Raman active. And next we look that both Raman and I are active. We'll erase it. For both IR and Raman active. So we see that all are Raman actives and IR actives are A2s are not IR actives. Okay, so for both Raman and IR actives, which is common for both, so that is excluding A2, all are IR and Raman active. That is 9A1 plus 8B1 plus 3B2. These are the both Raman and IR active. Okay, so likewise we will calculate. So not only we have to remember that for calculating modes, that is translational or rotational, what is say that exclude stoichiometric coefficient. And for calculating IR Raman active for both IR and Raman active include stoichiometric coefficient. Include stoichiometric coefficients. Okay, so today after this, thank you.